Vinisa, we are starting, will be starting shortly, maybe within a couple of minutes.
Yeah, please, because I might have to stop around 7:15. I think before that, I would like to take the questions and everything.
Sure, sir, sure. Just give me a minute.
Possible. Yeah.
Thank you.
Hello, I hope I'm audible.
Yes, Yukti, you are audible. Please start the session.
Okay, thank you, sir. Good evening, ladies and gentlemen. A warm welcome to all the esteemed participants to the third day of ATAL Online Faculty Development Program on AI and Digital Technologies for Sustainable Healthcare and Medical Technologies, organized by the Department of Electronics and Instrumentation Engineering, Institute of Technology, Nirma University. We are sure that you have enjoyed previous 2 days and we are thrilled to have you join today for day 3 as well. I am Yukti Shah, your host for the day. On behalf of ATAL Online FDP Organizing Committee, I extend my heartfelt welcome to each one of you. Your presence is a testament to the commitment we all share for continuous learning and professional growth. This event is more than just a series of talks or sessions. It's an opportunity for us to connect, share ideas, and be inspired by some of the brightest minds. We encourage you to engage, ask questions, and take away insights that can make a real difference. To make today's experience as smooth as possible, here are a few quick tips. Please keep your microphones muted and cameras off during presentation. If you have questions, feel free to use the chat box. We'll address them during the Q&A. Make sure your Wi-Fi connection is strong for the best experience. Now, let's get started. Today, we have an incredible lineup planned for you. Let us now begin by introducing our first speaker for the day, a true expert in their domain who will share valuable insights that are sure to inspire and empower us. With that, let's welcome our first speaker, Dr. Vineet Vashisht. He is an associate professor at the Indian Institute of Technology, Gandhinagar. He received a PhD in mechanical engineering from Columbia University, New York in 2015 and a Master of Technology in Mechanical Design from IIT Delhi in 2008. Dr. Vashisht is serving as an associate editor for IEEE Robotics and Automation Letters. He currently heads the Human Centered Robotics Laboratory at IIT Gandhinagar. The research work at HCR Lab uses the principles of human motor and movement adaptation to develop novel human-centered robotic technologies to improve the quality of human life. His research work has received funds from various funding programs, including the DST Inspire Faculty Award, SERB Early Career Research Award, SERB Core Research Grant, MHRD Spark, DRDO, LSRB, Good Cost, DST International Cooperation, IHFC IIT Delhi, Titan IIT Hyderabad, and IIT Gandhinagar. Dr. Vashisht's research interests include human-robot physical interaction, rehabilitation robotics, wearable robotics, and collaboration. He'll be speaking about AI-driven gait classification for health monitoring. So please join me in giving a warm virtual welcome to Dr. Vineet Vashisht.
Thanks a lot, Yukti. So let me see if I am able to share my screen. Please let me know once you see my slides. Are you able to see the slides?
Yes, sir, it is visual.
Okay. Okay, so let me. All right, so they are in the full screen mode and you can see my cursor as well. Are you able to see my cursor? Okay.
Yes, sir.
All right. All right. So thank you. Thank you very much for having me here. And thank you, Dr. Arvind, for inviting me and share my work here. So as Yukti mentioned, the things that I will be presenting kind of focus on GAIT classification. So the way I kind of assembled my talk is first I will be discussing. So there is a noise from the background. Is somebody has a question? Somebody is speaking. All right.
I'll request all the participants to please mute your mic. Ujma, Milan
Okay.
Basu,
Thank you. Thank you. We will really appreciate. I think if we can keep our mic off, and if there is any question, please we can speak in between as well. Wonderful. So to get started, so I will be speaking on gate classification. So the way I have arranged my talk is I will first talk about the gate per se. I work in mechanical engineering, but I am also associated with cognitive and brain sciences. So I will also give a context to this gate, how human perform this motion, and it becomes very important because we want to use sensors to detect it. So we must understand the origination of this and how do we approach this idea, right? And with this, let me get started. So first of all, I think many of us might have already visited us, but if you have not, please, if you're around the town or coming to IIT Gandhinagar, please do let me know. I will be happy to show you around. And I think this is part of our campus, the back side of our campus, behind which we do have a river. So I think it will be interesting if you visit, and I will happy to host you. So in our lab, I think the major focus is on developing human-centered robotics technology. At the end, I will also show glimpse of some of the robots that we are making in the lab, but the primary focus will be on the classification and the gate. So let's dive into that. So what is human locomotion? So walking, we all are familiar to that. As a infant, I start learning, and after a couple of years, I become good at it, and I only realize when I become subjected to some kind of disability or when I become older. And then I realize the main point of walking, so that I have considered this is so default for so long. But walking was never or not always the main way of locomotion. As our ancestor long back, I think they ape like. I think they were not using their limbs the way we use. So the way I think a lot of historians have gone through and understood the way human bones have developed, and that has resulted and given us an idea that how long back it was. So around 6 million years ago, the earliest human were actually just climbing the tree. But I think later than that, some changes in the bones, specifically around the hip area and the knee area, start changing. Now,